Hello students, today we will discuss about divergence of a vector. Suppose f bar is a continuously differentiable vector point function. That means it is a continuous function and derivatives of the function existed. Then whose divergence of the vector f bar is denoted with div f bar and defined as div f bar. Div means del dot f bar. What is del here? Del is gradient or vector differential operator. Div, D stands for dot. Div means del dot f bar. Sigma I dot dou f bar by dou x, because sigma I dou by dou x means del, but we are using here dot product between del and f bar, that is a sigma I dot dou f bar by dou x. It is used in vector identities. Now coming to f bar, suppose f bar is defined as f1i plus f2j plus f3k. While doing the sums or problems, we can use divergence of f bar, that is del dot f bar is div f bar, that is a dot product between del and f bar, del f bar. So I dot I1, j dot j1, k dot k1 and I dot j0, I dot k0, k dot j0. So we will have dot product between two vectors is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Whenever we compute divergence of a vector, the result is must and should be a scalar. Scalar means there is no direction, having only magnitude. Solenoidal vector. So what is meant by solenoidal vector? A vector point function f bar is called solenoidal if div f bar equal to 0. If we compute divergence for a vector, the result is 0, then f bar is called solenoidal vector. Also f bar, this function, whenever div f bar equal to 0, equation is known as equation of continuity or conservative of mass. Curl of a vector. Curl means suppose f bar is a continuously differentiable vector point function. The curl of a vector f bar is denoted with curl f bar and defined as del cross f bar, cross product between del and f bar. If there is a dot product, then it will be divergence. Here cross product, C stands for cross, that is in summation notation sigma I cross dou f bar by dou x. Suppose f bar is defined as look like to find the problems or to find the solution for curl f bar for a given vector point function. So we have to find out the determinant. So that is del cross f bar. The determinant must and should have first rows are ijk's, second row is dou by dou x, dou by dou y, dou by dou z. In second vector ijk coefficients are f1, f2, f3. Now coming to irrotational vector, suppose div f bar is 0, then f bar is called solenoidal, such that irrotational vector is also defined as the same. Suppose whenever we found curl f bar is 0 bar, the result is always a vector 0 bar. 0 bar means null vector, that is 0i plus 0j plus 0k. If curl f bar equal to 0 bar, then we have a unique relation between phi such that f bar equal to del phi. So there is exist a relation between f bar and phi. What is phi here? Phi is nothing but a scalar potential function. And we can compute phi also using the total derivative formula, which is already we known in partial differentiation. So that is a total derivative is dou phi by dou x into dx plus dou phi by dou y into dy plus dou phi by dou z into dz. So just we have to rearrange the terms. The terms look like the readily integrable combinations can be combined together, and just integrating on both sides we will get the required function phi. So phi is known as scalar potential function. So whenever curl f bar is 0 bar, then there exists a unique scalar potential function phi such that f bar equal to del phi. The problem is very important for 5 marks. They can ask, show that the given vector point function f bar is rotational. Also find the scalar potential function phi.